Hello students, in today's video I'm going to talk about measurements and uncertainties, a topic that is very important for the A-level students but more so for the IB students because they have a lot of calculations in which they have to take care of the uncertainties in the calculations, but it is overall important for all the students of science in chemistry, physics, and other allied branches. Now, the concept of uncertainty in measurement becomes a little difficult for the students to comprehend in the beginning because in everyday life, in our everyday dealings, we really don't understand that there can be an uncertainty in measurement. For example, a tailor is sure that he has taken the exact measurements for your shirt or whatever he is stitching. It is difficult or unreasonable to explain to him the idea of uncertainty. If we tell him that his measurements are uncertain, he will simply laugh at us and say that no, he has done perfect measurements. So the idea is difficult for the common man to understand. Now, the uncertainty and the precision are obviously important because if you look at the balance which is used by a jeweler, it is obviously a very sensitive balance because gold or the other jewelry that he's selling is very costly, and a small mistake uh, in his uh, in his measurement of mass can make a lot of difference to his profits, or he may be suffering a loss. So he uses a more accurate balance as shown over here, but even he thinks that he is making accurate measurements, and he may be right according to his needs. But scientifically, no measurement is exact. So now this needs to be explained in more clear terms. So uh, the the uncertainty that is associated with any measurement depends upon the precision of the instrument that we are using. In other words, if we are using a more precise or a more accurate instrument, then the uncertainty in its measurement will be smaller as compared to the uncertainty associated with an instrument which is not so precise. So, what do we exactly mean by uncertainty in measurement? Uncertainty in measurement refers to the range of possible values within which the true value of a measured quantity lies. For example, when we say that the mass of an object is 15.0 plus or minus zero point 0.1 gram, then this zero point 0.1 gram refers to the uncertainty in our measurement, which further means that the mass of the object may be not exactly 15.0 gram, but it may be about 14.9 to 15.1 gram. So we are trying to be more honest in our measurement when we are not exact. Now, the measuring devices can be one of the two types, either an analog device or a digital device. Now in this slide, you see obviously this is a digital clock which will which will directly give you the numbers associated with the measurement. Whereas in an analog device, you have actually to read it yourself. So these are the more examples of analog devices which are used in chemistry, like a volumetric flask, a pipette, a burette, a measuring cylinder, or a graduated pipette. So these, or a ruler, these are all analog devices where the person who is making the measurement has to read it. Whereas in a digital clock, the value is automatically displayed. That's the difference. So, as far as the uncertainty is concerned, there, there is the rule of thumb that we can apply. in knowing what kind of how much is the uncertainty associated with our device. So if it is a digital device, then the uncertainty is the smallest division. For example, here uh, this shows 55 1 minute and 55 seconds. So the smallest division is 1 second. So because it will show 55, 56, and so on. So the smallest division is 1 second. So the uncertainty is the smallest division, that is plus or minus 1 second. Whereas if you consider an analog device, then the uncertainty is the smallest division divided by 2. That means there is a lesser uncertainty in an analog device. So here the smallest division is 1 second. So here the uncertainty is 0.5 second rather than 1 second. Now let us consider more examples of uncertainty and how we are going to decide how much uncertainty we have to take into consideration. So this shows you a ruler where these numbers 1, 2, 3, 4 are the centimeter measures, and this 1 centimeter is divided into 10 divisions. So each division is actually 1 millimeter or 0.1 centimeter, and because this is an analog device, the uncertainty is 1/2 of the smallest division, that is 1 millimeter divided by 2, that is 0.5 millimeter, or 0.1 centimeter divided by 2, that is 0.05 centimeter. So when we are going to make a measurement, it may look something like this: 5.55 plus or minus 0.05 centimeter, which actually means that the exact value could be 5.55 minus 0.05, that is 5.50, or 5.55 plus 0.05, that is 5.60. So somewhere around this is the exact measurement. Now this shows you the thermometer. So now here it's an analog device, and here one division is actually equal to 1 degree. So half of that, that is 0.5 degree, is the uncertainty. Now when we read this, it is 20 it is slightly less than 24. So let's say 23.8, but because the uncertainty is half of the smallest division, so it is the 0.5 degree is the uncertainty in this measurement. Look at one more example. Here in this measuring cylinder, you see this is 100, and then 150, and then actually there are 100 and then 150. Here one division is actually 5 ml, because 105 and this is 125, so 5 divisions is 25, 10 divisions is 50, so one division is 5 ml. So because it's an analog device, so the uncertainty is half of that, that is 2.5 ml. But generally we quote only one figure, one significant figure for the uncertainty, so we'll round it off to 3 ml. So the uncertainty will be plus or minus 3 ml. So now when we read this, we should report the value of this volume as 125. It appears to be 125, but because of the uncertainty involved in the measurement, we will report it as 125 plus or minus 3 ml. Now we'll talk about the uncertainties in the digital instruments, and I'm going to explain to you that how the uncertainty will vary with the kind of precision that is associated with our measuring device. So for example, in this balance, it can read up to 0.1 gram, which means that when you weigh something, it could be like it could be this 5.1 gram, 5.2 gram, 5.3. So it will differ by zero point 0.1 units. The smallest it can read is 0.1 gram. It cannot read anything less than zero point 0.1 gram, and therefore the uncertainty associated with is the smallest division because it's a digital instrument, so it is zero point 0.1 gram. This is measuring in kilograms. So this here is once again the uncertainty is zero point 0.1 kilogram. Now suppose we change the balance and we use this kind of balance. As you can see, this is much more precise because you can see that it has it can read up to 3 decimal places. So this is very precise. For example, something which measures 5.1 gram here may measure which measures 5.1 here, and the same thing is now placed on this balance. It may show 5.105 or 5.123, something, anything different, but because it can measure up to 3 decimal places, so this will give you the mass of the same thing that we weighed here more accurately with more precision, and its uncertainty is very small, and it is the last division, that is 0.001 gram. That is the uncertainty associated by in using this balance. Similarly, this being a digital device, once again the uncertainty is the smallest division, so you will read this thermometer reading the temperature as 23.6, but there is an uncertainty associated with it, because if it were to be very slightly more than 23.6, then this thermometer won't be able to record it, and the next temperature that it will record will be 23.7, but it will not record anything between 23.6 and 23.7. So the uncertainty associated with this measurement is plus or minus zero point 0.1 gram. So after discussing this, in summary, we can say that no measurement is 100% accurate in scientific work, and we have to always quote the uncertainty that is associated with our work, and it depends on the precision of the measuring device. And the kind of device, the kind of precision that you will use will depend upon the kind of precision you want. If you want your measurements to be very precise, you will use a more precise instrument. That also depends on the nature of your experiment. Thanks a lot for watching. If you like the discussion, if you like the video, please give it a like and share it with your friends, and please subscribe to my channel, and give your comments, whatever you feel like about this video. Thanks a lot.